This video will show you how to use the Muon detector. And we have the detector, and this is the amplifier, and you use the computer software to collect the data. Okay, let's first connect the device, and you see the PMT, this black cable, connect the amplifier with the Muon detector. That's the middle connecting point. And the other one DC power input, and this cable connect the power, and that's behind the amplifier. And this is you see there is a DC power written over there. And the third cable is to connect the device with the computer. So this is the cable, and connect with the USB and to the computer. Okay, the software we're going to use is Muon. So you can find this one in the campus file documents. Okay, and the first step is to configure and select the port based on this one. And you can try either one, but I think this is the one that's connected to the computer. Okay, and then click Save and Exit. And let's start collecting. And you see the number. This is the number of the Muon detected, and that means it's connected. It's analyzing, connecting the data. So you can also turn on the audio. That sound also tells us that the device is detecting Muon. Okay, there are two numbers here. This is the number of the total number of the muon that has go through the detector, and there's also this total events. This number, this is recording the double events, the number of the muon that actually decayed inside this detector. So this is so far there are 10 that they decayed inside that device. So we're more interested in this number. So typically you need to wait for 24 hours to collect the data, and suppose after 24 hours and you come back, and you pause and quit, and let's save the data. Okay, and the data will be saved in this file, and the title is this is the year, this is the month, and this is date, and this is the time. So you can check the time. So for example, we just this is 12:38. The most recent file will be this one. To analyze this data, we're going to use Excel. Okay, so first we need to load the data and click Open, and here you will change the condition. This will show all files, and then you look for the file. So I'm going to analyze a different one. I'm going to analyze this one. This is the old data I collected before. And now it will ask you about delimited, and next, and click space. And okay, now we have the data. So the second column, and these are the time. So we don't need this one, so you can delete this one. And the first one, you see there are the number very high. So this is 40,000. So basically, if the number is greater than this number, basically mean that the particle the muon didn't decay inside that detector. So let's analyze the data. So first you highlight the data, click sort, and from smallest to largest. Okay, so you see this is the 40, mean the unit is 40 nanosecond. That means within 40 nanosecond there is a 1 muon decayed inside the device. And then there are 1, 2, 3, 4, 5, 6 muon decayed within within 60, the decay time is about 60 nanoseconds. So let's see what's the total number of the particles that actually decayed inside that device. Let's create another column to count the number of the muon that decayed inside the device. Equal to. So basically, this is the number of the rows. Okay. Okay, so we can find that we can see there were 1022 muon that actually decayed inside this device, and if this time is beyond 40,000, that means the particle, the muon, just go through and didn't decay inside. So we will just analyze this data. Next, I'm going to create a time column. So I'm going to, so these units are nanoseconds. So let's start with 20 seconds. So what I'm going to do is using the row number, multiply 20. This column is going to be our time, and the next I'm going to create a column to record the number of the muon that decayed by this time. Now, this column, we use the frequency function to count the number of the muon that actually decayed by. So, for example, the first one, within the first 20 seconds, there's no particle decayed, and the second one, within the first 40 nanoseconds, there is one particle decayed, and within the first 60 seconds, and the total number of particle decayed is 7. So let's pull down auto scale. Okay, so next I'm going to create a column. This one is going to record the remaining number of the muon by this time. So this is going to be equal to, the total is 1022 and minus the number that actually decayed. And into, okay, so let's drag down. Next, let's make a plot. So the number of the remaining muons as a function of time. So let's highlight this column and highlight this one. Okay, Excel will make the right column to be y-axis. Try scatter. And now we see this is the exponentially decayed graph. The number of the particles decay exponentially. Next, I'm going to calculate natural log of this function, and let's drag down. And next, you make the plot. This is the time, and this is the natural log of the number of the particle divided by the initial, and we get the linear phase. This is going to be a straight line. So, according to the theory, this line is going to be a straight line, and the slope of this line is going to be inverse. Is going to be inverse the lifetime of the particle. Now. And we can use this coefficient. You can find the find the lifetime of muon particles.